recording. Okay, so the recording started. So my name is Boris Demishev, and I will only teach one part of the course, R for Finance. My part is a little bit introductory. I will have only 4 classes. So basically, my main goal is to make an introduction into R and to show you how to estimate simple models, use it to forecasting periodic time series like ARIMA and exponential smoothing models. So introduction to R, ARIMA models, and exponential smoothing models. And the rest is by very good guy, Dean Fantazzini, who is like Italian mafioso. So he's very charismatic. So I'm sure you would like him. So okay, we have only 4 classes, and my goal is to just introduction to R, just to show you how to estimate an ordinary regression, how to manipulate data, cross-section data, time series data, and then how to estimate ARIMA and DTS. That's all. What about, so I'm responsible for my part of the course. And for my part of the course, you will have an assignment on, home assignment on data camp. And you will have 2 problems on exam, forecast, time series. So the exam is a little bit more or less predictable. The only major change from past years that great guy Igor Goncharenko has refused to teach his part of the course because he is working. So it's a pity because he's a good, he has a lot of practice. He's not an academic guy. He's like working in working with these models in real life. So it's pity for you, for me, but as we have, one part is mine, the second part is by Dan Fantazzini. So basically, for my part, we have 4 classes, we have home assignment on data camp, and we have 2 problems on the exam. And about requirements of by Dan Fantazzini, it's better to ask Dan Fantazzini. Okay? Yeah? Any questions?
Yeah, sure.
Okay. So now, to facilitate communication, I have organized a chat in Telegram. So I will publish invite link in ISEF information system, and I will just copy the link into Zoom chat, because Zoom chats are very bad. The information is lost after we close the session. So basically, I will post some important announcements in this chat to not lose any precious information. So basically, what do we need to make a home assignment and exam? You should register on DataCamp. So basically, if you have not registered yet, so I will provide you full temporary access for DataCamp. So you should register there. And you should register on github.com. That's for exam. And here we are, GitHub. So you should register on these 2 platforms. One will be used for home assignment, and the other one for exam. I will explain you how, but these are good platforms to study and to create software. I think that's all basically. I think, yeah, we can. So how we may use R? Basically, there are two popular ways. Either we use RStudio and or some just other text editor. I prefer RStudio text editor like Visual Studio Code, but some people prefer interactive notebooks like IP&B, but with R inside. So I will show you some ways. So if you are too lazy and you don't want to install anything, you may just use Google Colab with R. That's not a problem. You just type collab2/R, and you have so if you just type collab2R in browser like this, you will have an interactive notebook with R in Google Colab. So that's not a problem. So even if you don't want to install anything on your computer, you may perfectly work. What else? So, so I think that's enough. Let's start. I will show you RStudio. So I will share my screen now. Just a moment. Where do I share my? Just a moment. Oh, share screen. Yeah, like that. I think you can see my screen now. If you don't see my screen, just send me a message that something. So if you don't hear me or something is not visible, so just send me a message via Telegram or via Zoom. I will see it anyway. Okay, so we are in RStudio. I hope you have done a fresh installation of R and RStudio. These are two separate programs. RStudio is just a good, it's just like a code editor. It's not RStudio is not a programming language. R is a programming language, and you may use R without RStudio, but you cannot use RStudio without R because RStudio is just an interface. Okay, so basically, let's start with first mode. I will go to File and create new R script. Yeah. So basically, we can we create long projects and basically we work with scripts. So just a little bit of interface. You may go to console window and you may just type here something, I don't know, x is equal to 5 and then type x. But to save your work, we need to work with scripts or with markdown files with scripts. So I will show you just a little bit of scripting. So first, very basic approach. So every long script starts with attaching of different packages. So we will attach some packages because it's like in Python, like in every open source software. The major part of open source software is created by enthusiasts. And so we need all the power, all the functions, not all the functions, but some of the functions created by other people. So normally we will use tidyverse. It's like data manipulation package, plotting. We will use often Rio, just input, output. So if you'd like to import, I don't know, starter files, EViews files, I don't know what else, Excel, or basically any imaginable data format, SPSS, or I don't know which statistical software has you used, but Rio is a package that allows you to import basically any file. You just say import, and it will think by itself whether it's starter file, SPSS file, EViews file, I don't know, Gretel file, and so on. Okay, library for input output. What else? Okay, occasionally we will use Fable for time series, but I will not use it today. Just Fable for time series. And I will save a script. Okay, so I will save this small script just with attaching packages. R intro. Okay, I will create R intro. R for finance. R for finance. Like this. And I will create class 1 intro R. Okay, the file extension usually is big R, not small r, but big R. Okay, I will make a small breaks to ask you some questions. Everything is clear up to now? Any comments? Any questions? Don't be shy. No questions? I understand that you are too many, but really a good feedback is
everything is clear for now.
Okay. Thank you very much. Yeah, thank you. Because I need the feedback. I don't, because maybe you are just already lost, nothing works. Thank you. Okay, to execute a line, we just say Control Enter, but you can move, you can remap hotkeys, but normally it's Control Enter. So we just attach packages. So if there are some errors, or just a small question, that's important for me. I provide you options just how many times, just to understand who you are, just estimate how many times approximately have you run RStudio. Just put that number in the chat. Once, 10 times, 100, 1,000 times, how many times? So my question is, how many times have you launched RStudio approximately? I don't seek exact number, but to understand me that it's 1 or 1 million. Yeah, approximately. No exact numbers are needed. So just 1, 10, 100, 1,000. The precision is not enough. Is enough. Okay. Basically, I see, but okay. Okay, for those who are new, if you see some errors, so the good idea, because you are too many to deal with individual errors, but you may write them in the chat with a screenshot, and I may help you with some comments. So if you have some errors, just don't be shy. You may write them in Telegram chat, and someone, I hope, will answer you. But basically, when you attach packages, the main error you have either misspelled the name. For example, I have library Rio, yeah, and it will say no package called Rio, because there are no package called Rio, yeah. Okay, so maybe the name here's the error, maybe in the name of the package, or maybe the package is not installed. Okay, if the package is not installed, you just go to so if there are errors, check the name of the package, and if the name is correct, then maybe you need to install the package. So you go to tools, tools, install packages, you go to install packages, and you just type the name Rio and you say install. I will not do it because in my on my computer the packages are already installed, so I will not do it. But install missing package. So packages are attached. So this is called attaching packages. Attach package. So you attach a necessary package each time you launch RStudio. Attaching is done each time you launch RStudio. And you install package just once. Okay. So I see basically from 0 to 200s, I think, yeah. Yeah, from 0 to 200s. Okay, I see. Thank you very much. Okay, now let's move on to something more interesting. So let's use a data set, let's save it, let's read it, let's manipulate it. So first, input-output operations. So first, input-output operations. And then we will transform a data set. So the plan for today, I think, input-output operations, transform a data set. What else? Multiple regression, maybe some plots, and that's all we will do today. Maybe plots before regression. Yeah. Okay, input-output operations. If you have, my main warning to you is that on the web you can find a lot of code written for R, and sometimes the code is of bad quality, sometimes the code is of good quality, and for a novice, sometimes it's hard to understand whether, oh, this code is doing what I need. But for more experienced guy, you see, oh, that's a very ugly code. Yeah. So basically, first, I advise you 2 small visual checks that allows you basically to understand whether the code quality is good. They are not all. This is not a perfect check, but that's a good idea. First is code style. If you what I mean by code style, there are some basic rules like using fork and spoon during your meal. So basically, there are many code style rules, but some 2 simple code style rules are a space after every comma and not before. So if you see a code something like space after and before arithmetics operations. So if you see a code something like x equal to 5 plus y, so it's not a perfect proof that the code will be awful, but it's a first sign. The English queen will not do like this. English queen will do like that. So this is bad style, and this is Her Majesty the Queen style. Okay. So that's not a perfect sign. So there may be good, fast written code in ugly style, but it's correlated. A good professional will use a good code style. Okay, and RStudio warns you that expected white space, so it's a good code style. So basically, that's very simple. That's very simple. Two fast rules. There are code styling guides, but this is important. Okay, there is a little bit of two groups of our users. One group prefers to use assignment operator. So to execute a line, once again, for those who run RStudio for the first time, to execute a line or selection of lines, you hit Ctrl plus Enter. There are two types of assignment operator. So you may write x equal to 5. You may write assign 5 to x. You may write 5 to x. That's the same thing. So these three are completely, not completely, but in general, they are equivalent. There is a very, very subtle difference, but I will not go into details. Some times ago, I think 3 years ago, I preferred that notation. This is my old style. But now I moved to this style, my current style. You may use what you wish. But I think to make a code readable by those who know, I don't know, Python, C++, MATLAB, and something else, it's better to use more universal assignments. But these three are equivalent in general code. In some very particular places, very special places, you may feel the difference, but it's very difficult to spot the difference. What else? I think maybe the origin of this, the precursor of R language was S language, and S language was a commercial statistics language, and it was sold with a computer. And on that computer, there was a special key. This was one key, one special key on S computer. And that's why it's R has inherited this assignment with two signs. But basically, I advise my students to use that assignment, and that's okay. But Google style code, this is also, probably you know about Google. Okay, Google style guide. So programmers inside Google, they use this style if they work with R. And the historical reason that once ago in a time, that was a one key. Once upon a time, it was one special key on S computer. Okay, so I will try to follow good code style, and I strongly advise you to put spaces one space after comma, one space before arithmetic operation, one space after arithmetic operation, and that's cover, I think, 80% of good style code. Okay, input-output operations. So first, I may say, so let's use some built-in data set. So let's work with some built-in data set. We will look, let's say D equal to cars. Cars is a built-in data set. And I have invoked this data set from memory. You don't need to read it, just built in R. It's a very small data set. You may just look at it. Because it's very small, you can completely print it. So you may just type D and hit Control Enter, and you see the whole data set. It has only 50 observations, so it's very small data set. How you can also look at this data set? You can click on the data panel. Okay, if I click at D, I will see my dataset D. You may filter data here, I don't know, by some criterion, but I will close this data tab for now. Okay, how else? If the dataset is big, I can glimpse at my dataset D, and I see that I have 50 rows, 2 variables, and the first observations. I can look at the head. Head is a beginning of data set. I can look at the tail of the data set. I can look at specific lines of a data set. I don't know, lines from 3rd to 6th. Maybe I can look at some, but there are only 2 columns. But I may select some columns. Okay. I may select, let's select both columns. It's a stupid idea, but just to show you that I can select columns. Okay, these are speed list. Okay, like that. So now I will save my data file. So I may write something like export my dataset D, and I may export in any format I like. So if my colleague works with I don't know, with Stata, I don't use proprietary software, but if you are obliged to work with some colleagues, then and they so I may say like cars data. So I don't remember the extension, probably DTA. I don't know, maybe DTA for Stata. Who remembers what is the file extension for Stata?
DTA.
No, I think DTA. Okay, I have exported in Stata format. So I can export in, I don't know, export D, cars data, I don't know, CSV is the most simple, comma separated values, the most simple. So use this format. There is only one exception. If you work with very big data files, then maybe some other formats like Feather are more optimal, or databases, SQL are optimal. But for almost all sets of data, use the most simple formats, because this simple format you can open in any software. It's standardized. You can open it everywhere. You use CSV if you work alone, or if you work with other colleagues that can open a CSV file. But basically you can always export to Excel. So you may say cars data in XLSX. Okay, So that's also popular, but I strongly advise you to use CSV. So that's the most simple. It will remain for many years. So I don't know about the future of Stata and so on, and R and Python in 10 or 20 years. Maybe they will be dead languages in 20 years. Because 20 years ago, almost no one knew about Python or R. They were existent, but they were not so popular. About an error, the function export could work. Yes, we have attached only 3 packages. So to attach a package, I hit Control Enter on the corresponding library, tidyverse, library Rio, library Fable. To be more exact, the function export exists in the package Rio. So if you attach this package, this should work, export. If you don't attach the package, that will not work. So if I look, for example, help export, it will say me that export is a function in Rio package, and basically the syntax is here. Okay, so we have exported data. So my main advice: use CSV if you don't work with, I don't know, 10 gigabytes file. If you start working with 10 gigabytes file, then maybe you should move to some SQL or FISA format, but not before. Basically, it's the most simple and universal. You can import CSV in Excel, in Stata, in views, and so on. So basically, without colleagues, work with CSV. Okay, we may check, we may look, get working directory. So I work in, this is the folder where these files are saved. So this file is in my home folder. So basically, you can set another folder. So for example, I can set VD, like I know that my home Boris documents, and what else? It was R for finance. It was R for finance. Oops, and where it is, R for finance, where I have created where I have created R for finance. I don't remember. Sessions, one director to source file location. ISF R for finance. Yeah, it's ISF R for finance. Okay, and I may once again export the file. And guess how can we import a file? To import a file, let's say new data or something like this. New data equals to import, and you just write the name of the file. Cars data CSV. Hop, and the data is imported. We have the same data set as before. Okay, just a small break, 1 or 2 minutes. Have you succeeded to create a data file and to import a data file you have created?
Yes, sure.
Okay, so basically we know how to save a file, how to read a file, because that's important. I think I will, boom, 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 boom. I will send my current file. Okay. So if you are lost or something don't work, just pick up my file and it should work, provided you have installed these 3 packages. Now let's move on. So now we can open data file and save a data file. Basically, first knowledge gained. So if you have any errors, something does not work, just don't be shy, inform me. And obviously I cannot work with everyone for 20 minutes because time is limited. But okay, so next topic is how to transform a data set. For today, we will work with a cross-sectional data set. So there will be no special column like time or date. So for the moment, I work with cross-sectional data. So what are the basic operations with cross-sectional data? Let's use a data set that a little bit bigger. So let's use diamonds data set. Let's use D equal to diamonds. So this data set is a little bit bigger, glimpse D. It has 53,000 observations and 10 different variables. It's also a built-in data set. It's also a built-in data set, and we can create new variables, filter observations. So basically, first to it's a good idea to make our script a little bit to introduce sections. We may do like this. So attach package, and I will write 1, 2, 3, I think four minuses. Pum, 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 pum. And it will create a small triangle here. It's a collapsible section. This is attaching packages. So this is a remark about code style, and I can collapse this section. Okay, that's a good idea to have a script a little bit divided into sections. Okay, input output operations, 4 minuses, and I can collapse it completely. Oops, I don't need it. Oop. Oop. And all my code will be, I think, visible transformations, data transformations. Okay, and all my code will be here. Bum, bum, bum. The first transformation is very simple. We can create new variables. So if you work with big data set, so I will speak about, in this course, I will work with small or moderate size data sets. If you are interested in working with big data sets, so so maybe for bigger data sets, you should look at data table package. Or you should learn some SQL. For the moment, I will not care during my part of the course. I will not care about memory issues. So if your data set is 10 gigabytes and your memory is 16 gigabytes, obviously you cannot just copy and create another copy of your data set in memory, because twice the size of data set, you just don't have enough memory. But I will not care about these issues, and for medium-sized data sets, it's not a problem. You can just copy. So I will deliberately prefer to copy a complete data set to show you the difference between two data sets. But maybe if you are short of memory, that's a bad approach. Okay, D2, I will create a new variable. So first topic, how to create a new variable. Create a new variable. Variable or variables. Mutate. D, and I write the name of new variables. So let's say logarithm of weight. It will be logarithm of carat. Carat is the weight of a diamond. Yeah, we have 53,000 diamonds. Carat is the weight of a diamonds. Cut is a quality of a cut. Color is a color quality. Clarity is a clarity. Depth, table, and depth and table are some measurement. You may read about these if you just write help diamonds, because diamonds is a built-in data set. So you may read about the meaning of various variables. But I will create something. Log weight is carat, and let's say price carat 2 is carat squared, something like this. So I have created two variables at once in a new data set D2. Obviously, if I'm short of memory, I will write D and not D2, not to make a copy. But for educational reasons, I prefer to have a separate to show you the difference. In dataset D2, D2 is a table like a sheet in Excel. I have two more variables, log weight and carat 2. Okay. Have you managed to create a new variables or to edit an old variable? So I can replace. So if instead of y, I need cosine of y, I may write y equals to cosine of y. Okay.
Yeah, that was easy.
Yeah, creation of new variables. Next operation is filter observations. Filter observations. I like D3, filter D, and some criteria. I don't know, maybe cut is equal to ideal, maybe weight is bigger than median weight, something like this. Yeah. Is it clear what I will do? I will select these rows, these lines of my data sheet where the cut is ideal and the weight of a diamond. The weight of a diamond is bigger than median weight of a diamond. Okay.
Isn't it the carats, but not weight?
No, the name of the variable is carat because the weight of a diamond is usually measured in carats.
Okay, then.
So if you look at the description, yeah, you see that carat is the weight of a diamond. Carat is a unit of weights. It's like, who knows how much is one carat? Girls, you should know about weight of a diamond.
Not really.
That's a bad idea. How? So you should.
There was not the case where we encountered the weight of the diamonds.
So okay, just Google the carat. How much is one carat? Okay, so I will look once again at my D3. Yeah. Oh, that's a great idea. Okay, so I see that I have indeed filtered my data set instead of 53,000 observations. I have just roughly 8,000 observations. So indeed, I have filtered all cut quality is ideal, and the weight is higher than median weight. So, okay, so we can filter observations. Yeah, great. We have learned two basic workhorse. What do we do when we work with a data set? Okay. Second operation mastered.
Yeah, okay.
Yes.
Okay. Maybe the order, I don't know whether the order is important. Next is selecting columns. Selecting columns, you may say D4 is just select D, and I can just say caret price X, Y, Z, and glimpse D4. So I have selected columns. Okay. That's the same thing, but we select columns. We may also select, the other alternative is to say D for bis is just D, and we say like caret price X, Y. That will also work another way, but I think that one is a little bit easier because it has less ticks. It's faster to type. The result is exactly the same. I think glimpse D4 bis, that's exactly the same. But another syntax. I prefer that one. But that's okay if you use it. This one is like in Python. Okay, what else? The only warning here, just one warning. Because R is very big, so there are a lot of packages, and every author can invent a package. You may write your own package and create inside this package a function with any name. And basically the word select is very popular. And there are many packages with the function that is called select. And so if you attach here not tidyverse, but another package, like I think math, but there are many packages with function that is called select. So if you attach here another package, this line will not work because that package uses other select function. So basically, we go to help, I think help select. Let's look. Bum, 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 bum. Because I have attached only one package. So maybe I will do like this. Select. So it's a complete search, but my idea is the following. I don't like to search all the help for select word. My idea is very simple. If this line doesn't work, so maybe you have attached packages that contain the same function, select, and you'd like to use the select function from that package, not from this package. So you may just write the name of the package. So my warning is the word select is too popular. There are many select functions in packages. There are many select functions. So if you'd like to choose the right function and you have attached a lot of packages, because sometimes you need a rare package by some unknown author, so you may just write we need, so we have used help select, and our select function is from the package dplyr. So we write here dplyr, and to, like in C++. In C++, the syntax is the same. So basically R has borrowed a lot of things from C++, and the design of cycles, conditions is not like in Python with spaces, but like in C++ with brackets, with curly brackets. Okay, so if you'd like to use the select function from specific package, then just write the name of the package before. Okay, what else? We have done create new variable, filter observations, select columns. What else? Let's do some more. Oops. Multiple regression. What else? I don't know. Tools. Let's continue our quest. Sometimes we need to select a part of the data set to select a column not as a two-dimensional object, but as a one-dimensional vector. Go from 2D to 1D. So maybe I would like to, because D4 is a table, it has two dimensions. Yeah. So I may say, for example, D4, I don't know, row number 7, column carrots. Yeah. So, and I have one number inside. Okay, but so it's two-dimensional. Yeah, I need to specify row and I need to specify column. 2D4 is a two-dimensional data table. Sometimes I need to go from 2D to 1D. How may I do that? Either I may do like weight vector equals to, as I may say, I may use, I think, pool D4 caret. Yeah. And now way is a one-dimensional vector. So I have selected, I have decreased dimensions. So I may use element 7. So weight vector is a vector. So it's a one-dimensional object. 1D. 1D, I mean one-dimensional has one dimension.
You mean you extracted a column from the table?
I extracted the column. So I may also extract like weight vector. I think like this will also work. Oops, sorry, D4. No, that doesn't work. I think like this. Yeah, or like that. And go weight. That's another approach. Weight vector bis. Another approach to go from 2D to 1D. Okay, let's call it and back. If I need to create a data set from one-dimensional vectors to go back, let's create some vectors and go back to 2 dimensions from one-dimensional vectors. Let's create A, that will be vector 5, 6, 7, -8, NA. NA is a special word for not available for missing observation. Let's say B is C. C means combine. -2, 7, 4.5, NA 9. Yeah. And I may create my small data set is table. Table is like table but faster. Table, but faster. Just it has the same, basically the same pronunciation when you say table, but very fast. Table. It sounds like table. Okay, that's table pronounced fast. Let's say, I don't know, price is given by the vector A and the quantity is given by the vector B. And I have my small data set. It's 2-dimensional data set, 2D data set. A vector, and that is a vector. Boom, 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 and I can glimpse my small data set. Okay, that part is clear, how to go from 2-dimensional table to 1-dimensional vector, and how to create a table from some 1-dimensional vectors. That's okay?
Yeah, that's okay.
Okay, so we have finished that small part of the course. Just let me think a little bit whether we have something. Let's speak about other types of data. Other types of data. So basically, often we work with tables or vectors. I think that are the most popular data types. So tables and vectors. But sometimes we need to create more complex objects. Tables and vectors are the most popular. But sometimes we can create more complex structures. We can create structures that are called lists. Lists can be very, that's like a bag of, where you can put in this bag everything. So for example, my list is list, and you put a number, you put in this list a vector, you put in the list a data set, and you put in the list a function. Okay, so my list is a list of 4 different objects, and they are very these are objects of very different structure. So the first element is a number, the second element is a vector, the third element is a 2-dimensional data set, the fourth element is a function. So my list is a list of objects of various nature. So I can, Yeah.
I'm sorry, when in real life do we usually use lists?
When we usually use lists, when the output, so for example, you use you estimate a complex model developed by some other guy, and this guy needs to inform you about estimated coefficients. He needs to inform you about residuals. For example, you estimate ordinary least squares, and the result of least squares are a vector of coefficients. You may have, let's say, 5 coefficients, yeah, vector of 5. And you also sometimes need to analyze residuals, and you have 1,000 residuals, yeah, and to collapse them in a regression results, yeah, and these object regression results will contain a vector of coefficients, a matrix, estimate of covariance matrix, a vector of residuals, and maybe some other information.
So we can add to the list, for example, plots, diagrams, can we?
Yes, but normally we don't, with plots is a little bit, because with plots you are concerned to make, so you can, but I think that is rarely done, because normally when you use your plots for further to publish your paper or to make a coursework, probably you will save plots in a separate folder as a separate, let's say, PDF or PNG files. So basically, yes, you can, because list can contain objects of arbitrary type, but I think you will not with pictures. Pictures you will save in separate files. Okay.
Got it. Thanks.
So, but you can. Normally, the results of model estimations, when they are, for example, OLS, ordinary least squares, we have a vector of coefficients, an estimated covariance matrix, vector of residuals. And these are 3 objects of different type, because a vector of coefficient, it may have 5 coefficients estimated. A vector of residuals, they may be 1,000 residuals. And covariance matrix, it may be 5 by 5 matrix. Okay, so lists, usually lists are used to store estimation results. Okay.
Thanks.
Okay, I can use any element. My list, elements of a list are accessed with double brackets. So first element is 7. I can multiply, first element is 7, and I can multiply it by 9, and I'll get 63. The second element is a vector. Yeah, my list second is a vector, and for example, I can calculate mean of this list. It will say an A, because by default R is, so that's the difference, I think, between R and Python. Python is created by professional programists, and the code style of Python is much better. But R is created by professional statisticians, and in a case where the Python will choose a reasonable solution, R will be very careful to not make some assumptions without you. So there is a missing observation, how to calculate mean. You can just drop it, but maybe it will introduce sample bias. So you should be explicit about whether you are sure to omit it. So I may rm remove missing values, and if I say true, if I would like to remove missing variables, it will calculate mean, rejecting the missing observation. But R is very, in general, the strategy of R is to require assumptions from you, to be very careful in statistics. Okay, the last element was, my list my list. Third element was a data set, and I don't know what I can do for data set. I can calculate number of rows. I can glimpse as a data set. Okay, and the fourth element, my list 4 is a function, is a cosine, and I can take cosine of pi, and cosine of pi is -1. So we can store in a list objects of different natures, even pictures, but maybe that's not a good idea, but we can. Okay, so lists. So the main reason why we need lists, model estimation results are usually lists. Okay. Now we have, so even to be honest, the table is a list. So if you look at the structure of cars, it will say that it's a data frame, but honestly speaking, it's a list. It's a list of first column and second column, but this type of list is standardized. So it has a special name, data frame. So standardized list types have some special names, but honestly speaking, it's a list inside. So I may use something like cars, double brackets, when I try to extract one element from a list, and I can extract first element is the first column. So basically cars is a data frame. So basically everything complex is a list. So honestly, cars data tables are lists of standard type. Okay. Boom, 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 boom. To save lists, you cannot use because lists are very non-standard. So if you have a data sheet, then you use import export. But if you have some complex object, so in this case, you may need write RDS. So RDS, so avoid this format if possible, because it's a format special to R. And you will not be able to open it from, I don't know, Excel but sometimes if you save some internal object and not standard table, so you may save a list to save a list. Right, LDSD, my list, RDS, to save a list. So a list has very special type because the fourth element of my list is a function, and this function will work only in R. The cosine, yes, there is a cosine function in Python, but this saved cosine function, it has a structure that is special to R. And I may, and new list, I may read RDS, my list RDS to read a list. And as we know, new list 4 is a cosine function, and cosine of 0 is 1. Yeah, because it's a new list, it's a cosine function. Fourth element is just a cosine function. Okay, any questions about lists?
Probably not.
Okay, so I will send my...
Can I please ask a brief question?
Yes, 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 you are encouraged.
When you made a double bracket 4 and then pi, you have chosen the fourth element and then...
The fourth element of my list is a cosine. And basically I have calculated cosine of pi.
Understood.
Because the fourth element is just that element.
Understood. Thank you very much.
Sorry, I have the following problem. So just permission denied. So just check that you point to the folder you have right to, because so if you are working under Windows, maybe so just check. So if this function writer.ds throws you an error, basically you have no rights to save a file. So if you look at get.vd, I'm trying to write in a folder home Boris documents ISF. So I have, as a user, I have right to save files in that folder. But if you point into a folder that is prohibited from changes, maybe you are trying to save your file in the Windows system folder. So if you are trying to save a file in a protected folder, not documents, but something like C/Windows. So then it will refuse to save a file. So just if you have no rights, just change setvd and say something like, I don't know, if you are under Windows, then C user, C documents, I think, documents, users. Oh, but just copy available paths and I think it will work. On Windows, you may also something like Boris. So just a name of the folder. Maybe there is also some platform dependent part of the syntax on Mac OS and Linux. We use that type of slashes. On the Windows, maybe you need to write something like something like that. But basically, to not avoid the typing errors, you can just hit tab there. So I may try to hit home folder. This is acronym. This tilde is acronym for home folder. So I tab. So hit tab. Documents. I don't know. Azbuka. R and so on. So use tab to navigate, to have to save time. Okay. Save to source file location. Okay, I think we have created list, saved list, and read list. Okay, what else? Natural order of operations. Leonhard Euler was a great guy. He invented a big chunk of current mathematics, but maybe he made one big error. He created a syntax of functions. So that's an invention by Leonhard Euler and Alexis Clairaut. They invented what we know as f of x. So from school, we write something like cosine of sine of 0. That means first I should take sine, and then I should calculate cosine of the result. So calculate cosine of sine of 0. Yeah. So the order we start operations from right to left. And for European guys, it's strange. When you read text, you go from left to right. So that's a count. So we are used to it from school, but that counterintuitive. If you look at some food recipes, they say, take 1 kilo of meat, I don't know, fry it and add something. So normally you read operations outside mathematics. When you read food receipts, then you are doing anything instructions. First action is written first, second action is written second in the text. So that's only exception made by Leonhard Euler. He was a great mathematician, but that's a very counterintuitive for European guy. And so many languages fight with this error by Leonhard Euler. So in many languages, you either will see methods in Python. Why are there methods? Why functions are not sufficient? Because it's unnatural for a human brain, or for European at least, to read operations from left to right. So you would prefer something 0, take sign, take a sign. So that would be much better. That would be more intuitive. We are used to this notation. So we are used to this, but that would be more intuitive. And so in many languages, you see either methods, either other ideas to execute operations from left to right. I don't know, channels in terminal, in macOS or Linux, methods in C++, Python, and in R you have pipes. So that will be channels, methods, pipes to do this natural order. How we do natural order operations in R? We do something like 0, pipe, sign, or we may just write say that it's a function cosine. So basically that's the same thing, but with a natural syntax, natural order of operation. I take 0, I take sine, I take cosine. So the result is the same, cosine of sine of 0, but that's natural. You may argue that, oh, line 123, I don't remember where is combination for 5. You can look in help and find something like cheat sheet and RStudio. So there are a lot of good cheat sheets. I type it by hand. I don't remember where the hotkey for pipe. I think it's keyboard shortcuts help, and maybe it will be something. You may Google it. So I don't remember, honestly. There is a hotkey for pipe, but I don't remember it. So in this example, it may seem that natural syntax is it takes more time to type, but when you will do some more, so let's apply, yeah, Control Shift M. Okay, Control Shift M. Thank you very much. Control plus Shift plus M. Control Shift M. That's strange. It doesn't work for me. Control Alt and oh, I don't know. Maybe I have remapped something.
That worked for me.
Anyway, my idea that I will provide you an example where the natural syntax is more intuitive. Let's say I have a combination. I have a combo of actions. Let's say, for example, take diamonds dataset. That will be the first action. Take diamonds dataset. Then I will create a logarithm of price. Then I will create logarithm of price, and then I will sort according to log of price. Then I will filter, I don't know, x is greater than mean x. Then I will select filter top 5 observations with respect to price. Okay, I will have this, and let's do this for operations using classic Leonard Euler syntax and using intuitive but non-standard syntax with natural order of operations. And I think we will have a break. Okay, Euler style way to do this. So in Euler style way, we start from the last operation and we go on to the beginning. So first I would like to filter top 5 observations with respect to price. Top n, yeah. So I will need 5 observations with respect to price. Then I go inside. So I take third action. Filter x is greater than mean x. Then I move on to the second action. Sort according to log of price. We have not done sorting, so I will introduce sorting ad hoc. Arrange is a sorting observation. So I arrange according to log price. And then the first action, we create logarithm of price. So mutate diamonds log price equals to logarithm of price. So that's a very long code. So it works. And now I will do the same thing, but using natural style, natural order of operations. So in natural order of operations, I go from first to last. First operation, second operation, third operation, and so on. So I create logarithm of price. So I take diamonds, mutate log price equals to log price. Then I continue on the next line. Sort according to logarithm of price. Arrange log price. Then next operation. Filter, yeah, I will copy it. Filter, then I go to the last operation. Filter top 5, top n, n equals to 5 with respect to price. So basically that's the same thing, but it's much more readable. The result is the same. But I see the first action is on the first line. The second action arrange is on the third line, or on the second line. Third action on the third line. Fourth action on the first line. 4 action, 4 lines. That's all. And in that, guys, in that all the style, it's a classic style we have learned from school, but it's not as human readable as the second one. And I can obviously assign the result. Result equals to. Okay, and I can see the result. It's a data frame, but okay. Any question about natural order of operation and pipe? This is called pipe operator. So we have something like pipe is this sign. Any questions about pipes?
Could you go once again through the meaning of operations filter, arrange, mutate? I feel like I'm lost a bit.
Yeah, where you are lost?
Where the earlier style way, we use filter, arrange, mutate.
So that's difficult with the earlier style. Just forget about the earlier style. I advise you to use this style. So my idea is that if you have a lot of observations, if you are new, then do it line by line, and that's all. So you may always work like this. So line by operation by line. So you may say something like D2 is equals to mutate diamonds log price. So there is also a style without combination. So you create D2, then you create D3. D3 arrange D2 log price. Then you create D4. You filter from D3 x greater than mean of x, and you create result top n from D4 5 observations with top price. So you can do operation by line.
Okay, thank you.
Could you repeat one more time, please? What is pipe used for?
Pipe used for a natural order of operations.
But if I don't use a pipe, for example, as you did in the last 4 rows, what would happen?
Nothing. But I have not introduced intermediate variables. So here you have introduced D2, D3, D4, and I have not used them.
Okay, got it. Thanks.
So basically, yes, the result is the same. So no, that's not quite some shocking revolution, but like method in Pythons, I can use functions instead of methods, but sometimes that is faster. Anyway, even if you prefer that style, that's okay, or even that will work. But these two are more readable. So basically, the meaning is to. So what does it mean from programming point of view? The result of this action is used as a first argument of the next function. So basically, from the programming viewpoint, this pipe says, take the result of the function and put as a first argument of the next function. And it works.
And now it's much clearer. Thanks.
Okay, so let's make a break for 10 minutes and we will continue at 8 o'clock. So just to have a cup of tea, and we will continue with, so we have already introduced, so I think we will do plots, some multiple regression, and I think that's all. Yeah.
Okay, thank you.
Okay, bye for the moment. See you in 10 or 30 minutes.